this is just the basics. So the first thing you're going to notice in this book, besides the giant shadow from my camera holder, is this is the periodic table of elements, and it is broken up into groups, and rows. So you're going to have the main group metals over here with lithium and beryllium, sodium and magnesium, potassium and calcium, rubidium and strontium, cesium and barium, and francium and radium. And then you're going to have the transition metals here in the middle. You're going to have the metalloids, which are these grayish colors, so boron, silicon, germanium, arsenic, antimony are all going to be metalloids. And then you're going to have nonmetals and noble gases here in the far column. So your nonmetals are going to be things like carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, bromine, selenium, iodine, astatine, and then your noble gases are going to be helium, neon, argon, krypton, xenon, and radon. And you can tell I've actually had to duct tape the book. Because duct tape fixes everything, including chemistry books. So just like in the last book, we have the contents overview. And I've tried to change the camera angle a little bit so you can see it better without the shadow. You're going to have part 1, which is the basic tools of chemistry. Part 2, the structure of atoms and molecules. Part 3, states of matter. Part 4, the control of chemical reactions. And then part 5, the chemistry of elements. And then you have these appendices that are going to help you. They're mainly charts and lists to help you do things like name organic compounds, what your physical constants are, the vapor pressure of water at various temperatures, things like that. And then it breaks it down into what the actual segments are. So again, part 2 is going to start with atomic structure, atomic electron configurations and chemical periodicity, bonding and molecular structure, fundamental concepts, bonding and molecular structure, orbital hybridization and molecular orbitals, bonding and molecular structure, carbon, more than just an element, so carbon bonds. And we're talking about molecular orbitals, basically how bonding happens, and then bonding with carbon, so hydrocarbons and stuff like that. So there's a lot of things in this book. So I'm going to take it. I think what I'm going to do is find some basic pictures and go from there. So the one thing that you should know is that each of the elements are going to have certain colors to them. So carbon is always going to be black. Nitrogen is always going to be blue. Oxygen is generally going to be a reddish color. Phosphorus is going to be purple. Iodine is going to be purple. And so what you're going to find is that they are going to go by size and color. And that's important when you're going to be looking at chemical structures such as this. So all of the elements here are going to be carbon. These are hydrogen, and these are oxygen. And this is salicylic acid. This is what the compound observations, such as the color of a substance or its physical appearance. This is a model structure of DNA. The chains, which consist of atoms of oxygen and phosphorus together with sugar molecules, twist in a double helix. And the chains are joined by molecules called nucleotide bases. And those nucleotide bases are going to join in a very particular manner. Then we have a law. And when we talk about scientific law, that is going to be different than we talk about country or county or state laws. We can do an ASMR lesson on that as well. Various types of laws. An original hypothesis may become a law, and a law is a concise verbal or mathematical statement of a relation that seems always to be the same under the same conditions. So, for example, the law of gravity. Another example would be the law of thermodynamics, which is another course altogether. And then you have a theory. A theory is a unifying principle that explains a body of facts and the laws based on them. It is capable of suggesting new hypotheses. Now we can talk about chemistry on a couple of different levels. We have the macroscopic level here, so you can see water is boiling or a substance is boiling. That is a chemical reaction or a property of chemistry. When the atoms are heated up to the point where they are going from liquid to gas, you can have a symbolic representation, which is H2O liquid goes to H2O gas, hence what happens here. And then you can have the particulate representation, which is what's happening here. You can see these are water molecules. So you have the oxygen here in the middle, like we talked about, and the two hydrogen atoms here. And as they get faster and faster and faster moving around, they're going to spread apart, they're going to heat up, and they're going to evaporate in a boiling. And then in this book, it also talks about different aspects of chemistry and how they relate to the modern world. So, for example, the Clean Air Act. And then we have the chapter highlights. So once you read this chapter, you should be able to understand the general methods of science, understand the meaning in terms of hypothesis, law, and theory, be aware of the difference between quantitative and qualitative, appreciate the goals of science and the importance of serendipity, be aware of the moral dilemmas that can occur in science, begin to think of chemistry in terms of its main conceptual viewpoints, macroscopic, symbolic, and particulate representations, appreciate the importance of models and model building in science, and understand the ways in which risks can be assessed and managed, and how risks and benefits can be weighed. So we touched on a couple of those things in this video. Next, we're going to classify matter. So generally, we talk about the states of matter, okay, or the phase of matter. So is it a solid, a liquid, or a gas at room temperature or some other temperature? So a solid has a rigid shape and a fixed volume and doesn't change very much with temperature change. Liquids, however, do have a fixed volume, but it's fluid, so it takes on the shape of its container and has no definite form of its own. Gases are fluid also, but the volume of the gas is not fixed. It is determined by the size of the container. I think of it kind of like a goldfish, where a gas will expand to the size of its container, much like a goldfish will adapt to the size of its tank. Most matter is found in a solid state at low temperatures. So here's another good representation. Here we have solid, we have all of the molecules together mixed together into one. Chocolate chip cookie is heterogeneous. So again, heterogeneous appears uniform, but in closer examination it's not. So while you say yes, this is one cookie, it is in fact different pieces of something put together. Homogeneous is completely uniform at the macroscopic level, and it can consist of one or more in the same phase. So, for example, salt in water, it is all going to be of the same solution, and it's all going to have very similar. It's going to have the same concentration all throughout. So if it doesn't have the same concentration all throughout, and you can easily take things apart, then it is going to be heterogeneous. Then we have elements and atoms. And then again, we have a story about coral chemistry and broken bones. So I like in this book how it talks about perspectives. It says current perspectives, but the book is fairly old. It talks about the current perspectives of and how to apply the chemistry to everyday life. And then we talk about compounds versus just elements. So chlorine itself is an element. Sodium itself is a metal. But when you combine them together, they make salt, sodium chloride. Then we talk about physical properties. So physical properties are going to be the state of matter, the melting point, the boiling point, the heat of vaporization, the heat of fusion, density, solubility, metallic character, electric conductivity, conductivity of heat, not the same, magnetic properties, shape of crystals of a solid, malleability. Malleability is the ease in which a substance can be deformed. Ductility. Ductility is the ease in which a solid can be drawn into a wire. And viscosity is the susceptibility of a liquid to flow. Then we have density. That is a physical property. Density, the ratio of mass of an